So parent functions, let's start with, one that we know. A parent function is the simplest of the functions in a family. Like y equals x squared is the parent function for this more like embellished quadratic equation. Okay, so in the past, we've, come across a constant function, so for example, like f of x is equal to 3, that's the constant function. The identity function, f of x equals x. Why is it an identity function? Because if x is 1, y is 1. It's like an identity. If x is negative 2, y is negative 2. We have the quadratic function, which, gives you a parabola. And then we have the cubic function, which gives you this. And so now that we've learned more things about this, another like difference we can highlight in a quadratic function is that it's an even function. Cubic function is an odd function.
It clicked.
Right, now it's clicking. And then, okay, so then let's move on and let's talk about, okay, a square root function. Also, we've seen that before, looks like this. And now the square root function is important because we know that the square root of a negative number does not give a real solution, right? So over negative numbers, the graph can't exist, right? Because when we're graphing real values. So the graph can't exist over the negative numbers. And you see here how like this practically only exists over like half the domain, okay? Only for all the x's that give you real number values. So from there, let's come to, oh, you know what? Still on root x. So the domain is 0 to infinity, right? So that's the domain. And then, is it increasing or decreasing? It's increasing over its entire domain, right? So it's increasing from 0 to infinity the whole time. Okay, so now let's talk about the reciprocal function. When you look at the reciprocal function, this is f of x equals 1 over x. So let's talk about something. When x values are positive, will f of those be positive or negative? Positive. So for positive x values, y values are positive. That's how you can tell if it's above or below the x-axis, right? For positive x values, you get positive y values. For negative x values, we get negative y values, so it's below the x-axis. What if when x is 0? It's undefined, right? So x can't be 0. That means there is a vertical asymptote or an infinite discontinuity at x equals 0. So the vertical asymptote is x equals 0. Okay? Fabulous. So if I want a positive y value, do I take positive x or negative x? Positive x. If I want a negative y value, what do I take? Negative x. If I want 0 for y, what do I take? Is there an x value that would give you 0 for y? No, there is not. So that means y also can't be 0. Oh. Yeah, y also can't be 0. So there is also a horizontal asymptote, y equals 0. You see that? So this is how we're gonna do this. Okay. So the domain, right? The domain will be negative infinity to 0, 0 to infinity, and the range will be negative infinity to 0, 0 to infinity. Okay, good. Then we have the absolute value function, which is this. Now, the absolute value function can also be written as a piecewise function because here, right, this one, this is y equals x, correct? So from 0 to infinity, when x is greater than or equal to 0, that function is x. Okay? But here, this one is y equals negative x, right? So when x is less than 0, it's negative x. So actually, the absolute value function can also be written as a piecewise function, right? So previously, suppose you just had y equals x the whole time. So in the blue region, y values are positive. Now, if I want, this is f of x equals x. But if I want f of x equals absolute value of x, what I'm saying is make all the y values positive. So then you take this, you flip it up, and it becomes that function. Okay? So that's how that works. Okay. Transformations, we know, affect the appearance of a graph. And again, we've done all of this. A translation, we did it in the trig units as well. So you can have vertical or horizontal translations. If you have a vertical translation, it's f of x plus k, right? And if it's plus k, the graph moves up. Minus k, the graph moves down. You can have horizontal transformations. That's applied to the x. And so it's x minus h. If you have f of x minus h, it moves to the right. It's opposite, right? If you have f of x plus h, it moves to the left. So remember, if you had y equals x plus 2 squared, technically, you take this, just like phase shift, right? Solve it for x. X equals negative 2, so it moves over to the left. Questions on this? We've done this so many times. Okay, so let's graph then. Use the graph of x cubed to graph each function. Okay, so here we go. This one has moved down 3. So the center point is at negative 3. Now, this is x cubed, right? That means you're taking your x units and cubing them. So if I move to the right 1 point, I go up 1 cubed. So if I go to the right 2 units, how much do I go up? 8. All right? And then if I go left 1, down 1, and so on. So that's what this looks like. So do you see how very quickly you can draw a graph? Make it precise as well, okay? Here, we're moving to the right 4 and up 2, so here. And then again, if I go left 1, up 1, right 1, up 1, and so on, like this. So this will look like that. I will specify how many points you need to graph. Okay, let's do more. Let's do a reflection. Okay, let's do a reflection in the x-axis. We know how to do this, right? You have a reflection in the x-axis when you have a negative in front of the function. So for example, if this is y equals root x, this is y equals negative root x. Okay? Now, how about a reflection in the y-axis? For that, the variable becomes negative. So take a look at this one. Here I have y equals root x. To graph this, just like we said before, the x values have to be positive in order for us to be able to get real values, right? Positive 9, positive 16, positive 64, okay? But now, what if I have f of negative x? Now that's going to be y equals the square root of negative x. Now, okay, can I put a 0 for the red one here? Can I put in 0 for x? Yeah, I get 0. Can I put in 1 for x for this one? No. Can I put in negative 1? Yes. How about negative 4? How about negative 9? Right? So do you see how it will only exist over the negative region? And that's why it is reflected in the y-axis that way. So do you see how like it all meshes together? right? The domain in itself like maps it out for you. Okay, fabulous. Okay, so here we go. Negative x plus 4. So there is a vertical shift of 4. And then also a reflection. So if I go right 1, down 1, and then remember, like I want to take like perfect square increments. So if I go right 4, I go down 2. Right 9, I go down 3. So that's what that looks like. Okay. From the end point, yeah? Okay.
I thought I was.
Yeah. Here, I go left 1, up 2. And then again, if I go right 1, down 1, right 4, down 2, and then 3, right? Again, I will specify. Okay, so listen. Do you see how this is an endpoint? That's not for decoration only, right? The domain does not allow you to go past that point. So I don't know, like sometimes, like especially in algebra 2, this happens a lot. I'll get students that go past that. Like that's so wrong, right? Because how can you have negative 2 as the x? You'll get an imaginary number. Please don't do that. If I only took off like 1 or 2 points in algebra 2, I'll take off like even more in Precalc Hon because now you have a better understanding and that's just not okay. Okay, so here we go. Let's talk about dilations, vertical and horizontal dilation. So here is how this works. These basically, so if something is expanded vertically, it's multiplied by a, and that a is greater than 1. So if this is y equals x squared, this will be maybe y equals 3x squared, right? So if I go to the left 1, instead of going up 1, I'm going to go up 3, okay? Now, but if that number is between 0 and 1, so for example, if this is y equals 1/3 x squared, now if I go left 1, instead of going up 1, I'm going to go up only 1/3. Okay? Okay. Now, this one is different. So now what about a horizontal dilation? So suppose here, this is y equals x squared, and suppose this is y equals 3x squared. Do you see the difference now? The x is being multiplied by 3. So there is a difference here. And here's how that works. If I go right 1, first the function multiplies the 1 by 3. So really I went over 3 and I go over that much squared. Do you see that? So it's a little bit different. Okay? So first, so instead of, going up to 1, it takes me up to where like x equals 3 was. Okay? And it's similar for this. If I go over 1, first it divides it by 2, so half, and then it only takes me up as much as a half would have taken me up. Okay? All right. So let's put all of this to use. Okay. So here, okay, look at some, okay. So we got some, oh my gosh, this is like so algebra 2, right? But if we wanted to describe, how they're related, so basically here, there is a reflection around the x-axis, right? Why can't I? How come it doesn't work? So there is a reflection around the x-axis, And then there is also a vertical stretch. Okay? So this, we start here, over 1, down 4, right? And that's how this looks. So if this is an absolute value, you have to have a corner there. And here, this is just a vertical compression. So it's a parabola, 0, 0. Now, if I go over 1, I'm going to go up how much? 1/4. That's not a good thing to graph. So what if I go over 2? How much do I go up then? 1, right? Because it was going to be 4, but now we take the quarter of it. So for ones like this, I take like values that are going to be divisible by the 4, right? So like another one, I wouldn't take 3, I would take 4. 4 squared is 16, but a quarter of that is 4, right? And then again, like it's just, right, so quick. Because as we move past, right, calculus and stuff, like you just have to be able to like get this out of the way in like 5 seconds and then go to like actual problem solving, okay? All right, let's do piecewise functions one more time. Okay, so here we go. Yep. So first I'm going to do this one. The boundary I'm going to put is x equals 0 and y will be 3, but open, correct? Okay, now look. I don't need to be plugging in points, even though that wouldn't be wrong to do. I know what this looks like. This is mx plus b. It's basically going down with a slope of 1, right? So just draw yourself a graph that looks like that. Okay, so here we go. Right? And then the next one is, again, 2x. So the first boundary is 0. Closed, I get 0. The next boundary is 3. I get 6. Open. And then it's a square root, right? The first boundary is 3. So what would the first y value be? 2. Right? At x equals 3, it's 2, and it's closed. And then I'll put in another number that will give me a perfect square, like 8, and I'll get 3. And then this is going to be like an absolute, a square root, so just, kind of give it that curve. Okay? See? Easy peasy. Okay. Look at this one. We need to be a little bit aware, right? So the minute I see this, I think to myself, okay, absolute value, square root. So if this is an absolute value, x plus 2, I know it's an absolute value here at -2, right, with the vertex. And then this one is x minus 2. It's right. Like I can already see what it's going to look like. And then this one, it kind of, goes off. So let's see. So the first boundary I put in for the first one is 0. That gives me 2. Oh, it's open circle. Okay. And then now I'm just, a pre-calculus student, so I know how to graph this, right? I know how this looks. I know that there is a vertex at -2, and this looks like that, okay? Because I've been graphing absolute value functions for over a year, okay? Now, here I have 2 boundaries. At 0, this is -2, and it's closed. At 2, this is 0, and it's open. And I know what this was supposed to look like. This was supposed to be an absolute value with the vertex at the -2. So I know this is just that portion of it. And then finally, the last one, when I plug in 2, I get what? 4? Do I? Yeah. And then what else would I plug in? Like 7? What do I get? What do you guys think? 7? You do get 5. Okay, and then give it, right, like a square root thing. Okay?
Wait, would that be, it does not exist because there's 2?
Well, are you talking about the limit?
Or no, there's an infinite discontinuity.
No, there is not. An infinite discontinuity is a jump discontinuity.
Even though
There is
no
a
real
there is a jump discontinuity here. There is a jump discontinuity at 0 and at 2. An infinite discontinuity has got to have a vertical asymptote. Okay?
Because
Yeah.
there's no actual point on
Exactly. So the limit of f of x as x approaches 2 is dne.
Okay.
But and then f of 2 is also undefined. But this is just a jump discontinuity. Okay? Hang on, let me do the 0. The limit of f of x as x approaches 0, also dne. F of 0 is negative 2. This is still a jump discontinuity. Okay.
Oh, so any jump discontinuity is D.
Yeah.
Okay.
Yeah.
It's just about if
the f of x
goes.
exists. Yeah. Okay. Okay. Okay, now my favorite ones. What if you have transformations with absolute value? Now this you haven't done before, okay? If you have absolute value of f of x. Now another word for f of x is what? Y. That means you are putting the whole y values in an absolute value, making them all positive, okay? So this is f of x. This is absolute value of f of x. So take a look. Here is where the y values were negative. Why can't I draw that? Okay? But you can't have a negative y value when you put the function in absolute value. That means instead of negative 1 for y, it has to be positive 1. Instead of negative 2, it has to be positive 2. So you literally take that piece and you do a reflection around the x-axis and bring it up here. Isn't that cute? Right? Now, take a look here. This is different. Here, you have f of absolute value of x. That means the x values are being put in absolute value. So, take a look at this one. Suppose you have f of x is equal to x minus 2 squared. That's a good function for this graph, right? Okay. So now, when you have 1, right, in here, what would the y value be? 1. Okay? Okay. Great. But now, what if you have negative 1? What would the y value be? 9. Well, in here, right? It would be 9. Okay, so that's this point, right? But now, this is telling you f of absolute value of x. So now it's going to be absolute value of x minus 2 squared. So now let's put in x. When you put in 1, you still get 1. But what happens when you attempt to put in negative 1? The function doesn't let you. It says, no, not negative. Make it positive 1 first. You make this positive 1, and you get 1 again. Yep. So what happens is everything where the x's were positive will be okay. This region completely gets wiped out because we are no longer taking any negative x's. In its place, you mirror the highlighted part from the positives, right? So look at this. This is the highlighted part. You just mirror that here. Okay? Yeah. You don't, because whatever is, so like for -1, you have the same y value as +1. You know what I mean? You just clone the positive y values. So you can have a graph over the negative x values, but the y values will have to be the same thing as for the positive ones. Okay. So yep.
Wait, but isn't in the other one didn't the y's were positive though.
Huh?
In the other one, like the y's were positive. So
yeah, it's okay. It's not the y's. It's just that any x value you put in first changes to positive x, then you get the corresponding y. Okay? All right. So here we go. Let's graph f of x. This is everybody's, favorite thing. So right one down to here, up, up. Yes, this is what this looks like. I'm channeling algebra 2 here. You guys remember? Oh my god. So this is f of x. Now on this graph, I want to graph absolute value of f of x. So I want to graph g of x. That means I'm going to take all of the negative parts and make them symmetrically positive. So like this, okay? And then the rest of it will be the same. So the red one is g of x. We're going to do lots of practice with this. Now here, I want to graph f of negative x. That means, f of absolute value of x. That means, look, everything that was on the positive x side will stay. What is this one? This is 3, 4. No, this is 3, 2. So all this was from the original, the one in black, the f of x, that stays. Everything on the negative side got wiped out. So what do I put in its place? The clone of this. Exactly. Just mirror it.
Why'd you go down to negative?
Oh, did I? Oh, I was supposed to go down to -2. Here, like this. I know. But that's okay because I have more for next time. Don't you worry. Okay? So this is h of x. Okay? Yeah, so we did finish this, but don't fret because I actually have something else like for next time. Okay, so your homework for this is a worksheet. Okay? Yeah. Huh?